Robokit uses a library called cognitiveserviceslib to interact with Azure services like speech-to-text, NLU, and text-to-speech. The library includes some tools that make it easy to measure the latencies of these services. So to see it all in action, we're going to first launch Robokit. Okay, so Robokit's running, recording. Hey Robo, what time is it?
The time is 12:16.
Hey Robo, do you know any jokes?
Where does the general keep his armies? In his sleeves.
Okay, so that's pretty responsive. Now we can use some of these command line tools to measure the specific latencies of the phases. So these are these 3 JavaScript files, one for testing Azure Speech. We'll use that first. And what this is going to do is instantiate an Azure Speech API controller, which is part of the library, and then record for 3 seconds, and then return a transcription of the utterance and the time round trip data. So let's give that a try. So we'll say node. What time is it? Okay, so here we're getting an utterance, time is it. We get back an n best. So actually one of the n best is what time is it. But the first one that came back, or the highest confidence, is time is it. And we're seeing a latency of 383 milliseconds, which means that after recording stopped, it took 383 milliseconds to come back with that transcription. Now, interesting thing about Azure Speech is that, so we're not doing any audio end of speech detection here, so we're going to record for 3 seconds. But if the speech-to-text service decides that you've stopped speaking, then it will return earlier than 3 seconds. And we can see that if we sort of speed up the utterance. What time is it? So in this case, we're getting back basically a reported cloud latency of 0 milliseconds because we got a recognition event at 2.4 seconds, which is less than the 3 seconds we've allocated for recording. So that means that end of speech detection happened in the cloud, and that's pretty cool. So we'll just try that again. What time is it? So again, we got back a end of speech recognition or a recognition event before the 3 second time limit that we'd set. And in this case, we got what time is it as the response, 91% confident. So if we use up all 3 seconds, then we can expect to see something like 200 to 300 milliseconds of time to get back a response. But if the system detects end of speech before 3 seconds, it's going to come back seemingly immediately. So let's test the NLU. So the NLU test is going to instantiate a Lewis controller, which is also part of the library, and it's going to send up the text, what time is it? And then we'll get back an intent and entities, if there were any, and the time information about the round trip. So let's run that. So in this case, we got back that the intent is launch clock, which is how it's defined up at Lewis. That's correct, and it's 95% confident. And it took 493 milliseconds. So let's try that again. This time we got 410 milliseconds, same intent. So there's some variability there, but pretty consistent. And then we can also test the TTS. So the TTS test script is going to instantiate an Azure TTS controller, again, part of the library. We'll send up the text, the time is 10:32, and that'll get rendered into audio. We'll get back time data about how long that round trip took, and also a WAV file that contains the audio that comes back. So let's run that. Okay, so we got back a result in 271 milliseconds. That audio file, you can listen to it.
The time is 10:32.
Okay. Run it again just to note the variability. 282 milliseconds, 258. For a short utterance like this, we should expect about that result. So then the library itself, without getting into too much detail, includes controllers for TTS, NLU, and then ASR, or speech to text. They all wrap this client class, the Azure Speech Client, which is based on a module called Bing Speech API Client, which is maintained part of up at NPM. Although Azure did update its API recently, and so that particular module is a little bit out of date. But this module does basically the same thing, although it's packaged in this library that includes these abstract controller classes. And so it handles talking to the specific endpoint URLs that Azure exposes. These are the defaults, but they can be overridden through a config object. When that config object comes in, if it has a speech token endpoint or a speech to text endpoint or a TTS endpoint, then it'll override. And then it has a recognize method, which actually wraps recognize stream. And so the audio that's recording is handed up to the service as a stream. Let's see if we, so as a Node.js read-write stream. And so while the recording is happening, the audio is being sent up to the service. And then that covers a whole bunch of latency, so we don't have to wait for the audio to be completely recorded for the service to start acting on it, or at least for that audio to get up there. And then there's a method synthesize stream, which is used for TTS. And there's a number of properties that can be used here in terms of voices, words using the male voice. And then there's a method that handles getting the auth token that's required for each of these calls. So that auth token request happens first, and then the call is made to the service. So that's just a quick overview of the library itself. All right, and again, the Cognitive Services lib, it's very useful for testing Azure services, and then can be used to implement those services in an application like Robokit.